Hello, I'm Edgar Kramer from Sunstate, Australia. I'm here today with Edwin van der Klee Rinveld from Siltech Cables. Hello, Edwin.
Hello, Edgar. Thank you for having me.
Good to see you. Edwin, I'm going to jump straight in out of the gate and ask you a tricky question. What makes a $150,000 cable?
It's a very valid question because as an audiophile, you have to spend your money on the things that really work for you. In the past, cables were seen as a kind of accessory that is only connecting unit A to connect to unit B. That's a very logical thought, and to be honest, as an engineer with a master in electronics, I was quite convinced when I took over this factory that to do anything, I wanted to kick out the cables. Until some staff told me, well, listen to this. And then having some experience with a large corporate that I work with and did research, I thought I have to put up a program to find what are the causes of sound differences, because they were quite spectacular. For the same reason, I refused to make power cords for 20 years until I was proven wrong again, because they make a huge difference. But now we know why. And only when we are convinced it does something, we are willing to do research, to spend money on it, and to make a product out of it. The products that we make are guaranteed to work very, very well in just any system. And because we export to 60 countries or more, we want it to work in any circumstances. One of the biggest challenges for cables is this. It's connecting A to B. On that route, which is just a little current going through, and a voltage, which is the variation of the audio, a lot of things are happening. So basically, it's a chain of the weakest link, you could say. So if you have a chain of events, you have your source, which is the ideal thing to start with, your source, your CD or whatever it is, your streamer, your turntable, your tape deck. That's the highest you can get. It only can go downhill from there. It's not marketing talk, but it's the fact what it is. So you try to maintain the quality until the end, until it reaches the loudspeaker as high as possible. Since many years, we are able to do measurements. So when I took over the company in 1992, so I'm not a founder of Siltech, but I took it over in 1992. I very hard worked on a program to find these minute details that kind of spoil the sound. And one of the things that we found is that very small artifacts can jeopardize the pleasure in listening to music. It's like, you can't put it in percentage. It's like if you have a good wine and you add a couple of drops of salt in it, just a pinch of salt, it may be 1 part of a million, but it still spoils the whole wine. So now we want to know what kind of distortions are so critical to our hearing system. And I have mentioned, and maybe before with you, I'm a musician myself. I'm in music all my life. I played on television when I was young. I was clarinet, concertos, and at home we have we had a Steinway. Now we have a Bösendorfer. So I did use these things to look into it. We also have a violin, a very high-end violin, high-end bow. We did a lot of research, and we still do, to see what makes good sound. And we're kind of coming closer to the clue, the reason that sound is really good. So unfortunately, to reach these objectives of this, you need very high quality materials. So the conductor itself is like a river where water flows through that has to go as smooth as possible. Otherwise, the water splashes everywhere. The same with electrons. You get a kind of noise, which is a kind of distortion, which is very clear, very easy to hear. And it is usually about 100 dB down, which means 100,000 times less than the signal. And still, it spoils the sound. You suddenly say, yes, the highs are good, the lows are good, everything is fine, but it doesn't make music. It sounds almost irritating. You will have that experience with a lot of products that, yes, it should be good, but it doesn't sound good. So those are these minute distortions. So the standard sine wave testing is not useful for cables. We can measure them nowadays. We can measure 160 dB down, very deep in the noise. We do that with special amplifiers that have a very narrow bandwidth of only a third of a hertz or something like that. So we have many ways to see what's going wrong. but basically the integrity of the musical signal, and it's the same for a musical instrument, has to be maintained. So if you have a violin, which has strings and a bow, you want immediate response. So if you ask a violin player, a real good one, a professional violin player, they have a word for it. I don't know the English word, but it means that it talks immediately, that it immediately starts working when you touch it. The lower the quality is, the longer it takes to build up a tone. So the immediate response is something very important. The immediate stopping of a signal is important too. So to give a very simple analogy with subwoofers have a high mass. They usually, when they stop, they still move a couple of times. So while the next note of the bass player is already playing, the old note is still echoing through your room. That's why we are not a fan of subwoofers, because most subwoofers have this booming effect. Yes, they give deep bass, which is great with cinematic things, but on real good music, it usually is counterproductive. You get deep bass, but it takes on too long. So here we have something, this has to do with the insulation. So the current is carried through the conductors. Not to avoid any distortion, you have to have the highest purity of metal. And it's not very critical if it's copper or platinum or gold or silver. It's all quite equal in sound if the purity is the same. But if I want to refine copper to a 8-9 purity, which means we just count the number of nines, so 99.99999. How many nines is you call an 8-9, 9-9, 6-9, and so on? It's just a simple way of saying it. So only with ultra purity copper or ultra purity silver, which both have very high conductance, you get undistorted results. But to refine that to that quality, silver and copper are getting the same price, because the base price is almost minute against the refining cost. To make such high purity is extremely expensive. Why do we choose in most of our cables not for copper? Some we have, but some are monocrystal copper. The other ones are made of silver. Silver has another big advantage over copper, that it never oxidizes at room temperature. It oxidizes in high purity only after 450 degrees Celsius, which will never happen in practice. Unless your house burns down, then you can throw away the cables. So anyway, yeah, that's a silly thing to say, but anyway. So this purity is extremely important. Then the other thing is that if there are always some variations in smoothness on the surface, the smoother the surface, the better. Incomplete crystals will become complete over time due to temperature. Temperature means atoms are moving and they move into grid at a random timing. And that makes that silver cables, pure silver, high purity, otherwise doesn't work, gets better over time. They sound smoother and smoother over the years. So even after 20 years, that still happens. With copper, it's the reverse. It oxidizes at room temperatures, so it slowly degrades. That's when you compare a 10-year-old Siltech with a 10-year-old other excellent brand with copper cable, they sound terrible.
So this is a concept of positive aging that
positive aging
refer to. Yeah,
it's very strong. We have it from day one, really from the beginning of Siltech. And when I started looking more into the crystal structure. Before we had so-called long crystals, and that was a long way from long crystals to one single crystal from the inside to the outside. So some people refer to the Ono process. That's not the process that we are using. We have a single crystal from input to output. That's also why we try to use we do use single crystal pins for the RCA and the XLR and the spades. It's all the same material and it behaves like one uninterrupted path. So yes, it has ultra low resistance, but it's not critical. It doesn't have any barriers causing a distortion, which is audible. So we now have the perfect conductor, but then the second thing is the insulation. Insulation, we all know what is capacitance. Capacitance works like a battery, like a car. If it's empty, you still have to fill it, and then it slowly drains again. The problem of capacitance in a cable and the quality of the capacitance, that's a whole different thing that people never talk about, but it's even more important. The quality of the linearity of the capacitance is much more important than the amount itself. But basically, it stores a little bit of energy, and it gives it back later when there's no sound. That means it smears out the sound. So when you, from whatever other brand you have, if you switch to a Siltech cable, suddenly you say there's more contrast. It's more clear what I'm hearing. And that's not just fantasy of the audiophile listener. It's exactly what they tell all over the world. And in measurement, it's confirmed. The silent pieces in the music are silent. So if music stops or another, sorry,
go on.
No. So this is very clear what is happening. And then you get more contrast. The music is very easy to separate. You hear the instruments separate. So there's a lot more scientific knowledge in the cables than a lot of people admit. I think the biggest problem for us is a lot of competitors that have no research at all have the same fantastic stories. We sound the best. We are better than this and that for whatever reason. There's of course a lot of marketing, but it's with any product. And the proof of the pudding is in the eating, and in our case, in listening. So actually, we have the most loyal fan base in the world. Siltech also fetches the highest second-hand price in the world, even if they are 40 years old. No other brand matches that. And for any listener or viewer of this, just check on the internet, look at our brand, second-hand, and others. And some people said, I bought a brand new Siltech, it's only used 2 years. And they ask a serial number to check. I said, well, the cable's from 1993 or 2001. And they say, but it sounds so fantastic. I said, yes, it does. Because it even sounds better than it was in 2001. Because the positive aging never stops.
Concept again, yeah. That's right.
So that's also the reason our cable lines run very long, about 7 to 12 years before we change. So every time when we launch a new series, it has to be so much better than the previous series that we stay ahead of the game. And also that we are not bypassed by the old cables who are slowly getting better over time. Sure. So that's why we use new technologies.
Edwin, I wanted to ask you just something that you mentioned earlier about measurements. And I wanted to ask what if you can take us briefly through some of the processes and testing equipment that you use when measuring conductor metallurgy and basically the cable that you're developing at the time.
Yeah. So for the metallurgy, that's separate. There are different ways with atomic absorption. There are many ways that you can analyze the purity of the metal. And you just get a percentage, and you get a percentage of metals that don't belong there. So usually in copper mines, you will find some traces of iron, some traces of nickel. Very often that's nearby. There are not many silver mines in the world, sometimes a side product of copper mines or from gold mines. We prefer the ore, and in the past we even directed it ourselves, and now we just do an analysis and think this ore is okay to use, because for us the traces that remain in there are very critical. We don't want any metallic component. I'll give you just an example. If you listen to tube amplifiers, a lot of people will say, which have the power amplifiers have an output transformer with copper winding. A lot of people have the feeling that the bass is not controlled, not tight. That's a disadvantage. Compare as beautiful as the mid-range is, the bass usually is not as controlled. The common thought is that it's because of the higher output impedance. We proved that already 25 years ago. It has nothing to do with it. It's not the output impedance. We modified transistor amplifiers to have high output impedances. They still sound the same. There's a little variation, but not the bass control. We found it's very simple. It's traces of nickel and iron, who are both magnetic materials. So if you keep a magnet to it, it sticks to it, isn't it? What does that mean? That it gets the polarization when current goes through. When you have a low beat note, a low bass note of 30 hertz or 50 hertz, that means for a quite long time it's positive before it turns into negative and then positive again. So the metallic components in your wire will switch direction. They take up energy, cause distortion, because they just pull out of the signal some. And then when it goes from positive to negative, they have to switch back. We found that to be the whole reason of not such good bass performance of the amplifier, so the tube amplifier. So we made, as a demonstration piece, the quite famous now SEPA amplifier, built in 1998, extreme tight bass, and it has an output impedance of only 1/4 of an ohm. So extremely high by any standard, and it's as tight as a big 500 watt transistor amplifier. What did we do? We use extreme high purity silver wire in that output transformer, 4.5 kilos of it, silver gold actually. Nowadays that would be too expensive to make, but it was to prove our point subjectively and objectively that it's true. So in our case, we need the highest purity, and the impurities may not be certain metals. So that's one test. For electronic testing, of course, we have 3 AP systems, the highest level of AP, which you can use for FFT analysts, but we make a lot of equipment ourselves. So we need, sorry, I got a call in there, just a second. So, sorry for that. So one of, with the measurement, we use lock-in amplifiers. A lock-in amplifier is an amplifier that, for instance, is used by CERN to detect only a few or one particle. With a normal analysis, you cannot do that because you don't have the energy to capture it. So the measuring itself will spoil the results. We have a lot of time-based analysis tool that are engineers. So we have fantastic engineers with PhDs. We have one who majored in physics, has a PhD in physics. We have people who work in acoustics, in electronics, analog, electronic, digital. We all need that, and they work as a group together to develop these tools because they're just not there. On the market, we can't find the right apparatus to cater our needs. And all these things make actually only one thing, that we can sieve out just very, very small minute details in the sound and analyze that. And this way we found what cables are doing. We can analyze power cables very easily. Why is a power cable working? It's a magnetic field with leaks out of it around it. What is the range of the magnetic field? Only 0.5 meter. So we also have magnetic analysis tools, 3D tools. That means you get a 3D image of the magnetic field, which is very critical, not two-dimensional, three-dimensional, and it works on a range in microtesla up to 1.5 megahertz, which is fantastic for audio cables and even for certain high-frequency cables. So we have all the test tools. We have TDR machines, you know, the 53,000 euro Tektronix, which basically was invented for HDMI measurement because that was, of course, very high frequencies and they had big problems with separating the channels. So we have the best of the best that we can buy. And if we can't buy it, we make it ourselves. All these tools are absolutely essential to make fantastic cables. We use multi-layer insulation. The insulation, because it's part of that capacitance, has to be of the highest quality. So we only use DuPont materials. DuPont is the inventor of Teflon and many other plastics. And we use the high-tech plastic. PEEK is a metal plastic that is used in military a lot. Why? Because it's very stable. It can handle a lot of pressure. It doesn't break under high voltage. It doesn't break under a lot of mechanical pressure. And not even at high temperatures. So you can raise the temperature to many hundred degrees before it starts deforming. A lot of people have that experience. They have a Teflon connector. They think that the world of a Teflon connector, let's say an RCA. And when they solder the wire, then they find that the middle pin is loose. Why is that? Because the Teflon gets soft, hardens again, but you get a little bit of play. With Kapton, that will never happen, and with PEEK, that never happens, but they are very advanced and difficult materials to work with. Your basic question was a simple one. Why is it so expensive? To do all these things, it becomes ultra expensive. To make an extrusion of PEEK, it's very expensive because if the material hardens, the machine's costing way over 1.5 million euros. They get blocked and clogged up, and they are very difficult to clean because it's as hard as steel. This artificial material. So it's a very complex process, but if we do it, we get the fantastic results. Not for a reason you had with this story about the Master Crown, which is ultra successful cable. Despite its high price, everybody wants to have it because it's so good. And it proves the point that cables can make a huge difference when done right. Don't look at the price, test it yourself. Yeah.
Sure, I wanted to touch on that and basically get your personal opinion on this because Master Crown uses Siltech's S10
Plus
alloy or new
S10 Plus, yes. Yeah.
That's right. Okay. Yeah. So just briefly, can you tell me what sonic qualities do you attribute to S10? as compared to the previous generation, or
I would say
that you're using?
okay. Well, long story short, in 1997, I invented the G3 technology. G1 was original Siltech with random crystal growth. G2 was long crystals. And in G3 was the first silver gold alloy. What we wanted was a perfect crystal structure. In those days, it was possible, but at ultra high cost, and it took a very long time to grow these crystals. Half a meter took half a year or something like that. So I looked at another way to not have these boundaries between the crystals. So I made an alloy, and in the metallurgy, we did a lot of experiments until it worked in such a way that all the distortions were almost vanished. So from what we could measure in those days, which now is almost 30 years ago, was that the distortion, the measurable distortion then went down by 30, 40 times compared to the standard that we had before, which was already 3 to 10 times better than our nearest competitor. So this is what we did. And we looked also at step response at nanovolt scale. That means if you have a little input step, what does the output follow that in a linear way? So is every change in signal at the input, which music does all the time, exactly followed on the output of the cable? And we found it didn't. That had to do with the quality of the materials of the insulation and sometimes with the configuration of the cables. So back to the silver gold, that was actually the most affordable way, which was near the quality of a real single crystal cable. Later, we were able to make at acceptable cost, still very high cost, monocrystal cable. You have to realize in the audio, when I wanted to buy my first cable as a student still in 1973, I think the first one was Monster cable. They had these big copper cables for your loudspeakers with a transparent jacket of PVC. I bought it. I had to pay 200 Dutch guilders, which was roughly $100, so something like 150 Australian dollars, for a 5-meter pair. And I said to my retailer, I said, never in my life I'm going to pay 200 guilders for 5 meters of cables. Because until then, we used the cheapest cord we could find to connect our loudspeakers.
Yeah.
And that's, of course, funny if in hindsight, we had to realize, we had to learn that quality is everything in sound. And the awareness and the acceptance for paying a higher price for cable took a long, long time. So that was in our favor that later in 2001, when we had the first monocrystal cable, the quality was very good, but there were still impurities in it. And actually, with every generation, we tried to limit the impurities by a factor of 10. Why 10? Because we think that is just enough to make an indent in quality jump. That you say, okay, but that's something you hear. Do you hear 3 times? Yes, but in some cases not. So 10 times sounded to us like an easy step. So it's 1 9 more. So the purity in the very first one was about 4 nines. Then we very quickly switched to 5 9 purity. So that's 99.9999, and then usually 7. And every next generation is about 10 times better than the previous one. And also what we changed, because with the previous generation, we found some variations in the impurity, which is normal thing. And now we select even based on the impurities. So we only we throw away everything that is not the highest of that quality. So let's say it's a kind of random process that about 60% we achieve what we want and 40% we don't, which is still extremely good, but we don't use it. So these are the processes that are becoming increasingly difficult, but we are still managing because our knowledge is gaining too. Sure. Of course, also with the surface quality, the surface smoothness, the constructions, we have a lot of computer models that we all develop ourselves. So we have come a long way to reach this quality. And again, we try to stay ahead of anyone else. And I'm not jealous if someone else makes a fantastic cable. I'm happy for them. But if it would be better than mine, I would work very, very hard to beat them again. So in that respect, So just see it as a Max Verstappen against Hamilton, or Norris now. Sometimes it's you can't always win, but at least we're trying very, very hard.
Sure.
Yeah.
Okay, I wanted to touch on the connector quality because the Master Crown has some very impressive connectors. So are the connectors, both the RCAs and the XLRs and even the Spades, are they manufactured in-house at Siltech?
Yes.
Or
All
do you have a
designed and laid in-house.
Partner or?
No, we all do that in-house, completely actually. And there's a good reason for it. We started with that with the SST connector. There was an RCA connector in 2001. Already then we found that the connector was limiting the quality of the cable. So when we developed a new series, we found this difference to be in measurement big, but when they were mounted with connectors small. So we started measuring connectors too in those days already. We can measure very accurately a soldering, a crimping, a mixed technology, a friction technology, ultrasound welding, that's called. All inductive welding, we see all the difference and all the distortions that they create. So we thought we have to make something much, much better that also follows the quality of the inner wiring. So we make parts that are 3.2 millimeter thick of S10 plus now, and that's in the connector. So you get exactly the same. It is a pressure contact, so it behaves like it's one piece of metal, so you don't get the crystal boundary effect. And then we solder it for security because we are not sure what happens after 10 or 20 years. So we want it to stick together. So these are the technologies they use, but they make a huge difference. And then it stops. We can't control the quality of the input and output connectors on the apparatus that our customers have. So if they have whatever brand it is, some do a better job than other. Sometimes you see good quality WBT, sometimes you see really low quality connectors, which I find a shame because these manufacturers, if they would put on better in and output connectors, they could really up the quality of their own product without doing much more. Only it costs more money.
Sure. I noticed that you kind of made a concession to that by having the RCAs and the female end of the XLRs with a pressure screw to tighten the interface between your connector and the male connector and the socket on the other side. Yeah.
For that reason, you don't have to. For that reason, you don't have. What I want to say, it's. You shouldn't use fluids. You shouldn't use fluids because the fluids very often don't oxidize our contact because they're extreme purity. But the side that's on your apparatus sometimes it oxidizes the layer below the gold layer. You only make it worse. For a short time, it sounds very often better. And then people find that they have to keep doing it. They say, well, the fluid really works great. Yes, because they oxidized it in the first place, which usually takes 2-3 weeks. And they put fluid on again, and with a cleaning cloth, and they say, oh, now it sounds good again. But actually, they ruined the connectors. So no matter what these manufacturers say of fluids, I would be very wary to put any fluid on it. Make them clean with a cloth. Of course, you can use alcohol or distilled water or whatever. That's all fine, but nothing else. Because these aggressive materials, they only have a short time better sound until the layer under the gold deposit, which is on top, which is very thin, will start to oxidize. So in our case, we have this pressure contact. Also, the XLR has that, and it works beautifully. You never have to plug it and unplug it again because under pressure, there's no way that any dirt or oxidation can come between it. So it's a very stable connection.
Sure. Okay, I wanted to just touch on the changing structure or recent changing structure of International Audio Holding. So that's the umbrella company which incorporates Siltech, obviously, Crystal Cable and HMS Cables, which is a recent acquisition for International Audio Holding. How do the companies differ in terms of design and product type? And is there a lot of engineering shared between the different companies?
It's a very good question. Yeah, a little bit tough to answer, but I will try. So basically, the philosophy of both Siltech and crystal cable is extreme high purity, very good resistance against stray magnetic fields, so that it's independent of your home situation, your location, the other units, that it always will bring out the best sound in your system. That's our goal. That's what we're trying. So it's ultra pure, and you could say simple, very simple, not very complex designs, but with very high purity materials. DuPont insulation, ultra purity conductors. Fantastic shielding. We are the only one using in some products monocrystal shielding. HMS, when we contacted the owner, Mr. Strassner, which is a physicist by himself, he started in 1975 with this cable HMS, but before he delivered to CERN. CERN is the big loop in the mountains in Switzerland, where they try to do experiments to find a way to achieve atomic fusion. Atomic fusion is almost a way to get almost free energy without any form of radiation. They know it's possible for at least 50, 60 years now, but they are getting closer every day, but they need these huge research. So what they do, they have a huge circle, I think 15 kilometers diameter or something like that, and a single particle, a single atom actually, is bumped into another particle, and that flash has to be recorded because the energy that comes free from it has to be recorded in an instant. For this reason, Mr. Strasser developed the lock-in amplifier that I talked before, that has a very small bandwidth and is able to just detect one single particle. It's very different than all the audio measurement, which actually is millions of times worse than this kind of systems. And that's why we had to move to those kind of systems too. So when I talked to him 2 years ago, I was impressed by the knowledge that I had. And then he said I had a couple of friends, because he knew so much about magnetic energy, magnetic fields, and everything that belongs to it. He's an expert in the field. Some friends of him asked, that had a hi-fi hobby, can't you make a cable for us? Because all the blah blah of cable manufacturers, I want a real product. He did. To be honest, the philosophy of HMS, I would say, is 180 degrees the different direction, the opposite direction of Siltech and crystal. But I loved it because his goal is the same as ours, having a cable independent of its environment, but he achieves it in a totally different manner, and also with great success. So there are often more ways, as we say, more roads to Rome, leading to Rome. In this case, I thought this is fantastic. In a how do you call it, a very short time, we get all the knowledge how to do it completely different, and I think that adds to the knowledge of our company. And combining both things will give even better results, and that's the phase that we're in now. And still, they will have their totally own character, because there are a lot of followers for the HMS sound. They love it, and they want to hear exactly what HMS stands for. And we are able to keep that kind of sound profile as it is. A lot of people say, isn't that a bit strange? A cable should be neutral, it shouldn't add anything to the sound. They're totally right, but the fact is that all cables add a lot to the sound. They are not neutral at all. I mean, it's very, very simple. They all do a lot of things. It doesn't mean it's a color like it suddenly gets very dark or you lose the high frequencies. That's what people think about alteration of the sound. No, it's in subtle details, in distortions. So this HMS had a huge, a very scientific driven company, adding to our knowledge base. And this is why we wanted to take over our company. So it's like if you have a Porsche 911, it has the engine in the rear, and it has rear wheel drive. Another sports car may have a lot of experience with a motor in the front, a front wheel drive or four wheel or whatever combination. Let's take a Dutch Viper or something like that, rear drive, a big engine in the front, 10 cylinders, whatnot. They both achieve similar results in speed, but behave different on tracks. And one will be better in straight ahead and the other one in a curved road, and you know which one does better already, I guess. Anyway, if you can combine the experiences of both and have all this experience, it's not simple things, a lot of fine details, then you're set yourself ahead of an even better quality company that can also deliver the next generation of super products in our field. Sure. And that's the whole reason so when we bought the company last year, it took us about a year to understand all the ins and outs of an HMS product. So we said for 1 year, we will not change the product until we really have a grip on what makes the HMS sound. And now we can make the HMS sound, but a better HMS sound, without ever making it a Crystal or Siltech sound. And that's our, and even a Crystal and a Siltech are different in sound, and we also keep that. And it's not a matter of better or worse, but it's a different effect. And for a customer...
Sorry, I was going to say, sounds like there'll be lots of interesting things coming from the group as a whole.
You bet.
In the near future. Yeah. There'll be lots of cross-pollination between the different companies and the different experience bases.
Yeah.
Well, on that note, Edwin, I'd like to thank you very much for today, and look forward to seeing some of those products once they come out with a new.
The first product you have experienced is.
Yeah. And as far as viewers today, please watch out for my review of the Master Crown, Siltech Master Crown cables coming in the next few weeks. Thank you, Edwin.